everybody. Good afternoon. Thank you for joining us for the ThinkPlus webinar series. I'd like you to introduce yourself and put your, let us know where you're from into the chat. My name's Celia Franz and I am a education consultant. I work for Alivo Institute and as a schools research lead for ThinkPlus, developing resources for ThinkPlus. So today we're very happy to welcome the wonderful Dr. Jared Cooney Horvath, and also thank Alivo for sponsoring this free event for educators globally. I'll talk a little bit more about Jared when I introduce him, but for now, I'm just going to point out to you some of our social media. We are, ThinkPlus is on Facebook, and we advertise at most of our events on there. So if you're keen to join future events, then you might want to have a look at our ThinkPlus Facebook regularly. We're also on Twitter and Instagram. And we use these platforms to keep in contact with our teachers and schools, but everybody is welcome to be part of that group. And we'd really like to see you on there. So in the housekeeping, just a reminder, introduce yourself. I can see people are doing that, which is wonderful. It would be great to see where everyone's from shortly. I just wonder if you could keep your mics off if they're on, and we may ask you to turn your mic on later on if you have a particular question towards the end of the webinar. And if you have any comments, also pop those into the chat, and we'll keep a record of comments and questions so that we can consolidate things if they come up during the webinar. I'd like to begin by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islander peoples here today. A little bit more information. The Alivo Institute was formerly known as the De Bono Institute, and for those of us who have been teaching for quite a while, you will remember the hats. The coloured hats, we had them in our classroom, and they were wonderful. So they have been around for a long time. They have a new name, Alivo Institute, and they are a not-for-profit research organisation partnering with academics, universities and schools, and are experts in developing curriculum about thinking. Its educational design research focuses in creating resources for children to develop resilience and self-regulation to meet the challenges of the future ahead. And for over 10 years, our educational innovations have helped schools and teachers as researchers collaborate as developmental partners to co-create the ThinkPlus meta curriculum project, which is that illustration that's on your slide. So if you'd like to know more about ThinkPlus or Alivo, my email is down the bottom and our website is thinkplus.info. I'd like to acknowledge and welcome all the representatives from our ThinkPlus schools and other developmental partners who are joining us here today. And particularly board members of Alivo Institute and pre-flight web expert Scott Garrett, who is here to help us with all our technical issues. So moving on, take a breath. We're here. We're going to have a great afternoon. Just want to put a little bit of context behind some of the work that we have been doing, and in particular the work that Jared will lead us through this afternoon. During the long Melbourne lockdown of 2020, there was an opportunity to bring together some global experts and local experts to continue to respond to this kind of thing. And when I say this kind of thing, I mean the pandemic has really forced us to pay attention to how children are faring. I'll read this quote to you. And now my children are watching me. All day, every day, our children are watching us. And because we know kids are always learning, they are picking up lessons that will stick with them and shape who they become. Remote learning and teachers also juggling families, grandparents, multicultural groups. Everybody was forced into one space very quickly. And to that end, the future, what does the future look like, became a prominent question and a prominent focus for Alivo Institute. As a future-focused entity, the meta-curriculum responds to knowledge, skills and understandings. Is basically built around different knowledge, skills and understandings that children will need to thrive in the future. And the main concepts within this meta-curriculum are based on the child, neuroplasticity, mindsets and emotions, metacognition. So our research, excuse me, our research has just demonstrated the fundamental knowledge a child needs to thrive is all about thinking. So thinking about themselves and their identity, about me, thinking about their brain and how it works, thinking about their own mindsets and emotions, and thinking about their own thinking so as to become better learners. And to this end, a journal was produced through collaboration with experts from around the world and teachers as teacher practitioners in Melbourne, Australia. There was also a card game produced to respond to these big questions and help students understand the benefits of all of those learning areas. We were very fortunate to have Dr. Jared Cooney Horvath write some of our content in the ThinkPlus How to Grow Your Mind journal. And so today he's here with us to go through these activities that he wrote. And you may not know Jared, but if you do, you will know about his amazing From Theory to Practice YouTube channel, which is fantastic. Everybody has to go and have a look. So good. So what Jared does is he actually takes journal articles and research, he reads them, and then he interprets them for teachers and other academics and so on. So it's a really high quality, good learning, right, very accessible language, and certainly something that teachers can definitely use towards their BIT registration in terms of their professional learning hours, points and credits. So Jared is an award-winning cognitive neuroscientist. He's best-selling author and renowned keynote speaker with an expertise in human learning, memory and brain stimulation. Jared has published 4 books and over 30 research articles. Jared's resume is 19 pages long, and I read it all. And honestly, we are so lucky to have you, Jared.
Why would you read all that? Even I don't read that. It was
cool. It was really good. Like, I was really interested. I know I felt a bit like, should I read? Is this for me? But it was very, very good. I thoroughly enjoyed reading it. The most exciting thing for me was that Jared won the Dean's Award for Excellence in a PhD thesis in the University of Melbourne. I have been editing a PhD thesis very recently. So when I read that, I thought to myself, that is the most outstanding thing. So
that's the goal. That's the next level. You keep editing. Is it your own PhD that you're editing?
No, it's not my own. No, I'm just reviewing it.
It is a nightmare. That's why, if you can get some sort of award off the back of that, that makes those 4 years totally worthwhile.
It's definitely a love job. It's my partner's. So I want to talk about Jared's books too. So Jared has a couple of books that he's published recently, but he has some other books as well. If you want to find out more about Jared's publications, he has a website, learningmadeeasyglobal.net, which you can have a look at. And Jared's also on Twitter. So you can follow him on Twitter for all his latest news, and his YouTube channel is up there. So without further ado, I will hand over to Jared himself. Thanks, Dr. Jared.
Perfect. Thank you so much. And I'll throw my slides up. So hello, everybody. It is lovely to digitally meet you. One of these years, we'll be able to say, good to see you in person. But for now, we deal with what we got. So before we kick in today, I've got a lot of new people here today. Some are not new. So I just want to apologize in advance for those of you who know me. This is going to be repeat for some of you. But as always, whenever we learn something, the more times we hear it, the easier it is to sink in, easier it is for us to start to disseminate and make sense of. So maybe not a bad thing. And also, now that I'm sharing my screen, I can't see anyone anymore, unfortunately. I can only see my slides, a weird fluke of my Zoom for some reason. So anytime you have a question or a thought or a fear or a doubt today, feel free to unmute yourself and chime in. If you're like raising your hand or clicking on a button, I won't be able to see it. So if you ever want to jump in, just do it through the speaker. Otherwise, I'm not going to know what the heck is happening. And we'll have time at the end too to chat as well. So today we're going to talk about the coder. So what is the coder? What are we talking about when we say the coder? So to understand what we mean when we're talking about this, we've got to take a little trip through the brain. So for the longest time, we used to think the human brain was just an all-purpose meat computer, right? It's just an organ that thinks. You have lungs that breathe, you have a heart that beats, you got a brain that thinks. What more is there? But that can't really be the whole story. Otherwise, what happened here? So I'd like to introduce you to Phineas Gage. Now, Phineas Gage, he was a railroad worker back in the 1800s. And I guess when you're laying down railroad tracks and you get to a hill, you've kind of got three options, right? You either go around the hill, you tunnel through the hill, or you blow the hill up. So Phineas's job, he was a blower. He just blew things up. That's his entire job. And the explosive he uses is called black powder. So you probably know, like sparklers, that's black powder. When black powder is loose, it doesn't actually explode. It just kind of fizzes. So in order to make it explosive, you've got to compact it. You've got to tamp that stuff down. So one day he's got to go blow up a hill. He digs his hole, he fills it with black powder, and he's like, hey, I need something to compress this black powder. Engineer friends, do you guys maybe have a tool I can borrow? And they said, yeah, we sure do, big guy. We got this giant metal rod with a pointed end on it. Cool, thanks. So he puts this on his black powder, starts hitting it with his hammer to tamp it down. Now, question, what do you think might happen every once in a while when you hit a metal pole with a metal hammer? Yeah, so he comes down, kicks off a spark. The spark ignites this black powder and it shoots this pole up. So the pole catches him here right above the left jaw, goes in, takes his left eye out from the inside, totally liquefies the front part of his brain. This is gone. Shoots out of the top of his head. This thing lands 30 meters behind him. That's how much force it came up with. And what happened to Mr. Phineas Gage? Not only did this guy survive, he picked up his hammer and he went right back to work. The dude didn't even lose consciousness. Now, in hindsight, he's almost certainly in shock, right? Like he's not thinking straight. You don't blow off half of your brain and go, well, still on the clock. Everyone, let's get back to work. So he's not all there. But here we've got a guy who just lost half of his brain. He goes back to work. We were right? The brain is just an all-purpose meat computer. Look at him. You can tear it out. You can throw it around. It doesn't seem to matter. But then weird things start happening. So before this accident, Phineas Gage, nice guy. He's got a wife. He's got kids, just a normal dude. After this accident, things change. So real quick after this happens, Phineas decides, I don't really want to go to work anymore. So he kind of quits going. And fair enough, I wouldn't want to go back either. But then he decides, I don't really like my wife and kids anymore. So he kind of kicks them out. Then he decides, I don't really like people all that much anymore. So he kind of moves into the middle of nowhere and he becomes this curmudgeonly blah of a guy. Like he's still alive, but he just doesn't care. He doesn't do anything. The people who know him say, look, the Phineas Gage before that accident, totally different than the Phineas Gage after. Something changed. So it's from him we learned, turns out you don't have a brain up here. You've got dozens and dozens and dozens of mini brains all chugging away, all doing their own thing. So in his case, he loses all these brains up here. Things that give him drive, passion, want to hang out with my wife and kids, want to go to work. Those are all gone. Still got these back here, walk, talk, sit, complain, breathe heavily. So, all right, if we don't have a brain, we've got dozens of independent brains all doing their own thing. Question, how then does all of this come together to make one cohesive experience? If I've got dozens of independent things all chugging away, how do I have one coherent view of the world? And our primary theory for how this works is here. Now, anytime you talk about the brains, you're going to have to play this game at least once. So let's get this over with. So on the next slide, I'm going to pop up a bunch of colored boxes. All you got to do wherever you're at, out loud as quickly as you can, say what these colors are here. Sweet. Sweet. I'm guessing you did great. You know your colors, rock and roll. Round 2, I'm going to pop a bunch of words up on your screen. All you got to do, wherever you're at out loud, read these words as quickly as you can. Wonderful. So I'm guessing you did great. You know your colors, you know your words, and you all know where we're going. All right, let's do this. So on the next slide, I'm going to pop up a bunch of words, but each word is going to be written in a different colored font. Your job, out loud as quickly as you can, say what color each word is written in. So we don't care about the word, don't want to hear that word. We want to know what color the letters of each word are. Here we go, as quickly as you can. Let's see what happens. And are you getting it? Are you getting that crunch, that push, that pull? So what just happened? So go back. We don't have a brain. We have dozens of independent brains, right? You see something like this, the word red written in the color green. You've got one bit of your brain that likes what? Words. Does it care what else is going on in the world? Heck no. I am word bit. There's a word. I'm going to do my job. You got another bit of your brain that likes what? Colors. Does it care what else is happening? No, I am color bit. If there's a color, I'm going to do it. So you got word bit, you got color bit. We can feel these two different brains going, but in the end, you were able to select one of them out. It took you a second, but you were able to go red, no, green. So this means we must have a controller. Sitting somewhere within our brain must be a mechanism or a module or a node that can organize and coordinate all these other baby brains. Now, if you had to pick a spot in your brain where you think your controller sits, where do you think this guy might live? Now, if you're anything like us, our first theory was it's got to be deep in the middle, right? Because if it's in the middle of the brain, it has easy access to everything. But it turns out the middle of our brain is the oldest part of our brain. This guy, the controller, is the newest part of our brain. So what is the newest bit of our brain? That bit of the brain that only human beings really have in spades? The prefrontal cortex. So I don't know if you've heard about this before, but it's that big bit of brain right here, kind of behind our forehead. This is the thing that puts us on the Mars, that puts us on the bottom of the ocean. This is what makes us unique to other animals. Guess where your controller sits? And here's how we theorized it works. So the world must come into your body through your senses. All these signals, you get sight, smell, touch, taste, hearing, all these signals rush up into your brain and they trigger off all their little baby brains. So you get word bit over here, color bit over here, smell bit, face bit, dog bit. The next thing that happens is your controller, this prefrontal cortex, this thing that makes humans humans. It can coordinate and organize all the other baby brains largely by sending out one signal. Rarely does it turn things on. It's not a very, very big activator. The vast majority of the time, all it does is this. It shuts things down. It is a massive inhibitor. And here's how we think the brain works. World comes in through your senses, turns on your brain. Your controller can then go, nope, 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 nope. Shut down whatever it doesn't want running. And congratulations, whatever's left. That's our experience of reality. Now, an interesting discussion we could have, and we won't have it today, is that bit of the brain, that controller bit that shuts things down. That's the part that's really maturing during adolescence. So it's kind of going haywire. Now, what types of behaviors would you expect in a human being when the part of the brain that shuts off the rest of the brain starts to go a little haywire and overactive? Oh, maybe they would become disengaged. Maybe they become unwilling to communicate. Maybe they just sit on the couch and watch TV all day. Maybe they become like little zombies. If you recognize any of these little behaviors, that's what's happening. The part of the brain that's learning how to control the rest of the brain by shutting it down is maturing by becoming essentially hyperactive and turning off way too much. And we get these kind of teenage behaviors. Now, there's another brain mechanism that kicks in that leads to the crazy behavior, neither here nor there. But the point I just wanted us to see is that, yes, we've got this bit of the brain that is a massive inhibitor. That's its job. And this is how we, by and large, always thought the brain worked. World turns your brain on, controller shuts down whatever it doesn't want on, and whatever's left running, enjoy reality. That's how we thought for about 60 years until this happened. 12 black lines and one green square changed everything we thought we knew about the brain and how it works. Now, for some of you out there, it's already happening. But for the rest of you who are wondering, why are we looking at this square here? What I want you to do is I want you to imagine that green face of the cube. Imagine it's like a piece of glass so you can see through it. And I want you to bring that green to the front of the cube. So your cube starts on this green face here, goes away from you, down, and to the left. Okay. And if you got it in front, now I want you to push it to the back. Make the green the back of the cube now. So now your cube starts on this face over here, goes away from you up and to the right. And if you got the green in the back, pull it to the front. And if you got it in the front, push it to the back. Now, question you got to ask yourself is this: am I changing this image in any way, shape, or form? Like, am I flipping between two different images right now? No, of course not. So nothing about the world is changing. The wavelengths coming off of your screen, entering your eyes, turning on, activating your brain are identical right now as they were 10 seconds ago. Yet somehow you can see two different things. How are we doing this? Now think about it. If all we have is a controller that can shut things down, this should come in, turn on the brain, and the best we can do is see it or not see it. It's on or it's off. But here, not only can you see it, you can move it, you can morph it, you can tweak it. How are we doing this? Now, just because this is so important, let's look at another example. So on the next slide, I want you to imagine that we're in New Orleans, it's Mardi Gras, and we're going to go to a masquerade ball. So a little bit of fun. So here is the mask I have purchased for our masquerade ball. Whee! All right, now what I want you to do is I want you to imagine that while I'm at this party, I meet a lovely young lady, sparks fly, the night ends in magic. Now, thinking about me and this woman, I want you to focus only on the black and white portion in the middle of the picture and see if anything else jumps out at you. So have a look. Some of you are starting to see it. If you're struggling, I'll give you a hint. It's two people kissing. What? So if you can't see, so it's two people coming in profile for the kiss. Here, I've highlighted them. So here's the guy coming in for the kiss from the side. The woman's coming up to meet him for the kiss. Okay. So if you're looking at the kissers, pull your attention back now and see the mask. And if you're looking at the mask, zoom back in and see the kissers. Again, am I changing this image at all? Nothing about the world changes. The wavelengths entering your eyes, turning on your brain, identical right now as 10 seconds ago, yet somehow you can see two different things. How is this happening? Now, last one, just because I love these so much. And now you all know intellectually, everyone on this call knows intellectually that that square in the middle on top is exactly the same color as the square in the middle on the left. You all know this, but I guarantee you none of you see that right now. Right now, I'm guessing the one on the top looks like a nice dark brown, and the one over here on the left looks like kind of a nice little orangey rust looking thing. Cool. Now, all I'm going to do is fade out this image except for those two squares. I promise you I haven't doctored this. If you don't believe me, you can just cover it up on your screen right now. All I'm going to do is fade it out. See if you can feel the moment when you decide, no, that square is not orange. It must be brown. Now, all I'm going to do is bring that image back on. I promise you, nothing about this square is about to change. You can use any scientific tool you want to measure it, quantify it, bring in your physics, give me your wavelengths. It's going to stay exactly the same. But see if you can feel the moment when you decide, no, it can't be brown. It must be, I don't know, orange. Okay. Now let's pull our attention back. Why? What is it about this image that makes us think that square can't be brown? What's going on here? Now, you all probably got it. It has to do with lights and shadows, right? So everything in this side of the picture is in light, everything in this side is in shadow. Now, we all have tons of experience with lights and shadows. We have decades recognizing that when something moves from light into shadow, the colors, the tones of that thing change. That's simply how this world works. And here the world does exactly what you think it should. Green changes color, red changes color, white changes color, blue changes color. Everything's changing color except for this. You know what it should be doing. It's not doing it. So guess who simply changes the color for it? Welcome to the New World Order. It turns out we don't have a controller in the front of our brain. We have a coder. Sitting in the front of our brain is a module that can send signals back to every other cell within our brain. So not the programs, the baby brains as a whole, the cells that run each baby brain, tweak how those cells function at the molecular level so we experience the world in the way we think it should be, not in the way it actually is. And if that sentence didn't make you feel slightly uncomfortable, then you didn't understand what I just said. So let's hear it again. Sitting in the front of our brain and diffuse throughout is a module that can send signals back to every other cell in our brain, and we're now starting to learn outside of our brain. Tweak how those cells function at the individual level so that we literally see, hear, smell, feel, taste the world as we think it should be, not as it actually is. Easiest way to understand it is here. We've always spoken like this. The world is out there. It sends signals in. The brain chugs away. This is what we experience. This is reality. We now know this isn't true. Yes, there was a world out there. We are all living in something. But at any one time, we are pushing back. And it's this we've got to deal with now. And I know this sounds cute and fuzzy and new agey. Oh, look at the power of my thoughts. Yeah, I ain't kidding you. This is what I've got to put up with in a brain lab 24 hours a day, 7 days a week now. This is the game we are playing. This is the world we are inhabiting. So it behooves us to start to make sense of this and learn how to play these rules here. Now go back. Oh, we didn't do that actually, so I'll skip that one. But I'm hoping that this is all this would be a good point for questions. But again, I can't see if anyone's asking anything. So again, if you have any questions, please feel free to unmute yourself. Not going to bother me. But this is where things kind of get a little trippy. So this leads to an important question. If I've got a controller driving all of this, question, what's driving my coder? If my coder is tweaking how all of this works to drive what I see, what I smell, what I hear, what's driving my coder? What's guiding this thing? And in neuroscience, we say the thing driving your coder is your schema. In psychology, we tend to say it's your concepts, your conceptual map, and that's the term you'll hear me use most often. But the easiest way to understand it is here. It's your stories. The stories you use to make sense of the world, how it all works, how all the different pieces fit together, who you are, how you fit with those pieces. Those stories drive your coder. Your coder changes all of this, and that is exactly what you get. In a very real sense, your stories are driving your perceptions, not the other way around. And it goes to the perceptual level. Go back here. For the longest time, we used to think that color brown gets into your eye. Your eye sees brown. And just somewhere down the track, you interpret it as orange. Oh, no, we know that's not true. When you don't have a story running, when you're out of context, your eye sees brown, your brain sees it's brown from the moment you see anything. But as soon as you get a context and your coder goes, oh, it can't be brown, that sends signals back, and the very first cells on the back of your eye, on the back of your retina, change their firing pattern, and it's orange from the moment you see anything. It's not a down-the-track interpretation issue. It's an in-the-moment perception issue. Our stories are driving our perceptions through the coder. Now, how deep does this go? Like, this is real cute and fun when we're playing a little game on a screen. Oh, it's brown, it's orange, who cares? How deep, real does this get? To understand, I'm going to tell you a quick story. So a couple of examples of this. Our first story here begins here with Mr. William Gladstone. Now, Gladstone, he's a British politician. He was prime minister 4 times in the late 1800s, so big politico, but his true passion was Homer, the Odyssey and the Iliad. He loved these books. He treated these books like people treat the Bible. He thought the secrets to life were hidden in this writing. All we've got to do is find it. So our story takes place, Gladstone's in about his mid-30s. He's reading through the Iliad, trying to pull out secret meanings and messages. And at this point in the Iliad, Achilles, one of the soldiers, he's had enough. He's done. He's going to quit. And Homer writes that Achilles was going to hop into his boat and sail home across the wine-dark sea. So 4 words. This whole story starts with 4 words. The wine-dark sea. So Gladstone reads this and he thinks to himself, man, that's a weird choice. Look, I've grown up next to the ocean my whole life, and I've seen it a ton of colors. I've seen it dark, I've seen it gray, I've seen it black. I ain't never seen it the same color I describe a glass of wine. That's just an odd choice. So Gladstone starts poking around, and he notices Homer uses colors in a very strange way. So for instance, anytime Homer talks about iron, so like iron tools or iron armor, he refers to it as being purple. Whenever he talks about honey, Homer says that honey is green. Whenever he talks about sheep, at one point, Homer starts talking about sheep as being violet. So cool, sheep are violet to Homer. So Gladstone's like, man, something weird is going on here. So what Gladstone does is he goes to the Odyssey and the Iliad, and he just counts up color words. How many times does Homer use each different color? Let's just get a baseline. And he finds the most used color hands down is black. This appears about 170 times. Next is white. This appears about 100 times. Next is red. This appears 13 times. Green and yellow each appear less than 10 times. And one major color doesn't appear anywhere in either the Odyssey or the Iliad. What color was missing? Blue. It was just nowhere. So Gladstone's like, man, this is weird. So the next thing Gladstone does is he goes to all of Homer's contemporaries. Every single ancient Greek author he can find, he trawls through their work, he counts up color words, and he finds the exact same pattern. Whole lot of black, whole lot of white, a little bit of red, some green, some yellow. One major color doesn't appear anywhere in any piece of ancient Greek writing. What was missing? Blue. It was nowhere. So Gladstone has a think. He says, I figured it out. I think I know what's going on. Homer must have been colorblind. And by extension, every single ancient Greek author must also have been colorblind. That was his big theory, like prerequisite. If you want to be an author in ancient Greece, prereq, you have to be colorblind. Congratulations. So how do you think this theory goes down? So he says this, everyone kind of laughs at him, giggles at him like, dude, what? Go back to politics. And that's it. He gets made fun of, drops it, never talks about it again. 20 years later, this guy comes along, Lazarus Geiger. He hears about this. He says, I think there's something there. I want to keep digging. So what Geiger does is he goes through every major ancient civilization he can find around the world. So you name it, Egypt, Iceland, China, Japan, Vedic hymns, Hebrew text, you name it. Goes through all these cultures as far back as he can in their writing, starts counting up color words, and he finds the exact same pattern in every civilization around the world. The first colors to appear in every ancient culture are always black and white. The first true color to appear is always red. Green and yellow alternate. And the last true major color to appear in every ancient civilization's writing, except for one, was always what? Blue. It was nowhere in the ancient world. Now, one culture did use blue before the rest. One culture's language went black, white, red, green, blue, yellow. So they had blue before anyone else had blue. Any takers on who that was? Turns out it was the Egyptians. Now, why? Think about it. What did the Egyptians have access to that no other civilization had access to in the world? Oh, lapis lazuli. So if you think about it, blue is a ridiculously rare color in nature, right? Like there are no blue buffaloes roaming our plains. There are no real blue flowers. Most of our blue flowers are genetically engineered to be blue. They're not natural. In fact, to this day, the only natural source of aquamarine blue pigment we have in the world is right here, lapis lazuli. It's a stone mined in Afghanistan, brought down to Egypt. The Egyptians could crumble it up. They turned it into a pigment. They made makeup out of it. They made paint out of it. Geiger's like, I solved it, guys. It's easy. Until a culture can actually produce a color, that color is just not important to them, so they don't write about it. It doesn't appear in their writing. But once they can actually make that pigment, it becomes more important. They start writing about it. Cool. So the Egyptians had it. They wrote about it. They traded it. Everyone had it. Everyone wrote about it. Man, it's easy. I solved this. Mic drop. I'm out of here. See you later. And everyone said, dang, Geiger, that's a really good theory. Geiger said, I know that is a really good theory. Thank you. Too bad I don't believe it. Geiger said, what if it's actually the other way around? What if instead of until I can produce a color, I just don't talk about it? It's until I know a color should exist, it simply doesn't. So instead of until I can make that thing, I just don't talk about it. It's until I have a concept for that thing, there is no thing there for me to talk about. Now, how do you think this theory goes down? Well, as you can probably guess, dude got raked over the coals for this. He got vilified. People are like, you can't say that. That's mumbo jumbo. That's nonsense. And the biggest argument most scientists levied against him was that's not scientific because we can't prove it. And that's a good point. We can't go back in time. We can't ask these civilizations, hey, do you see this color? So it's an unprovable theory. How are we ever going to know? Well, cut to today. There is a tribe in Namibia called the Himba. We know their language. Guess what they don't have a word for? Blue. Now we can test this. I'm going to play a quick game with you. On the next slide, I'm going to pop up a bunch of colored squares. One square is going to be a different color than the rest. All you got to do wherever you're at, point to the square which is different than the others as soon as you see it. Here we go. All right. I'm guessing that wasn't too hard. If you look at this guy's face, is it that he's not trying hard enough? No, he just doesn't see it. Now, if you want to experience what this feels like, the Himba have about 37 different words for unique shades of green. So green, that is their color. It means everything from food to trails. That's their thing. In English, we have about 17 words we use for green. Same game. I'm going to pop a bunch of colored squares up. One is going to be different. Point to the square, which is different this time. Uh-oh. Now, I promise you one of those squares is different. And when I say one of them is different, I don't mean one of them is kind of different. I mean one of them is very different than the others. First time I saw it, I didn't believe it. I had to throw it into Photoshop. There it is. Now, if you're struggling, and you probably noticed if you didn't see it right away, it gets harder and harder to kind of pull out. But here we go. So keep your eyes on it. The answer is this one. It's the same one as before. Now, why? How is that different? Well, if you start to notice it, what you'll see is it's got a ton more yellow in it. Like not a little bit more, like an absolute huge amount more. So when you click on all these greens in Photoshop, just stays at green. As soon as you click on this one, the whole spectrum goes over into the yellow spectrum. Now, how many of you know this and you still can't see the difference? Well, watch the Himba do this. Now, I flipped mine so you could play twice, but here we go. Our stories drive our coder. Our coder changes all of this to drive our perception, and that's how this story goes. Our stories drive our perceptions, not the other way around. Now, there's one big glaring issue with this whole story. So that white guy, the researcher in that video that we just saw, he was coming out with this data about 14 years ago saying, guys, it looks like Geiger was right. And collectively, we're all losing our mind going, wait, that can't be true. Wait, what does this mean? But hold a second. This doesn't make any sense. Has anything jumped out to anyone as being kind of important and very blue, yet not discussed in this entire tale? What about the sky? Look, you don't need blue buffaloes roaming the plains. We don't need blue flowers. We're all under the bluest thing all day, every day. What about the sky? Well, I got some bad news for you. If this theory is accurate, then guess what? Turns out the sky ain't blue. The sky is only blue because we have the concepts that allow it to be blue. Now, how the heck would you ever prove something like that? Well, luckily, that researcher, the white guy in the video, he was about to have a kid. And like any good researcher does, when you have a kid, you run an experiment. So he has a baby girl and he decides, okay, I'm going to teach her the color blue. She'll know blue. Like she'll be able to point to like my microphone and say, that's blue. Fine. The one thing I'll make sure she never hears is that the sky should be blue. So she'll know the color. She just won't know that it exists up there. So the whole time she's grown up, they had to control like every book that was in the house. If it had a blue sky, she wasn't allowed to see it. Anything she saw on TV, anyone she talked to, she just never came across the concept that the sky is blue. So she's grown up, and he says, and if you ever get to hear him tell the story, it's incredible. He says she's a little older than 2.5. We're in the park. It's a perfectly blue sky day. Time to spring my trap. All right, let's do this. So he starts playing the color game with her. He's like, hey, baby, what color is that over there? Green. Yay. And what color is that over there? Red. Yay. He said, and then I did it. I pointed up and I said, what color is that? And he said, this bubbly, laughing, talkative girl just shuts up. And he says, come on, honey, what color is that? And he said, she looked up at me scared, like I was pointing at nothingness. So he's like, all right, let it go, drops it, moves on. Over the next 6 months, anytime it's a blue sky day, he takes her outside, he plays a color game, he says, what color is that? For 6 months, she doesn't say a word, just silence, crickets. Finally, she's a little older than 3. He's doing his thing. He says, hey, what color is that? She finally said her first word. What color do you think she said the sky was? I'd love it if she said green. Turns out she didn't say green. She said the sky is white. She said our sky is white. If you ask Homer and all the ancient Greek authors, guess what color the sky always is? It's white. If you ask the Himba, now the Himba were cool because we actually got to talk to them. To the Himba, the sky was either white, black, or gray. It was white during the day, black at night, gray largely around sunrise, sunset. On occasion, they'd see reds and oranges, but color in the sky just wasn't a big concept for them. But for the next 6 months, anytime he asked her, hey, what color is that? She always said white. And then he said after she turned 3.5, she started to pepper in the word blue every once in a while. And then by the time she turned 4, it was pretty consistently blue after that. But by then she'd started preschool and they'd stopped controlling everything she saw. And that's a real easy concept to come across. But here we go. Earlier, I asked you, how deep does this go? Something we take for granted so much as the sky is blue is only true because we have the concepts that allow it to be true. Our stories drive our coder drives our perception. Now, cool. This works with colors. Does it go anywhere else? Another quick example, just because I think this is too fun. So I want to play another game with you. So here's what we got for this game. We've got three objects. We've got a tree, we've got a doll, and we've got a house. Now, what I'm going to do is I'm going to place these objects in a certain position on a table, but you're only ever going to see two objects at a time. So your job is going to be to try and memorize where all of them are on this table so that once we give you a question at the end, you'll know how to answer it. So again, three objects, one table, but you'll never see them all together. You've got to memorize where they all stand on this table here. So picture number one. Here we see only the house and the doll. So try and memorize their location. All right, now for picture two, I'm going to rotate the table to make it a little harder. Here we see the house and the tree. So try and memorize their position. All right, and for our final picture, to make it tough, I'm going to rotate it back. Now all we see is the doll. So here's your question. If I were to give you that tree, where on this table in relation to this doll does that tree belong? Where would you put that tree? Now I'm guessing all of you are saying right up here. And congratulations, that answer would be completely and utterly wrong. Why? What in the heck is going on? Turns out the answer is that tree should be over here. Huh? This is another example of our stories driving not just our perception, but also our memory of the world. Remember, this is a memory game. This has nothing to do with taking it in. This is a memory game. In English, all of our language is self-centered. It's egocentric, which means when we talk about space and location, we do it in relation to us. So when we're looking at picture one, we place ourselves at the front of the table and we go, oh, the house is to the right of the doll. That means when the table flips, our language dictates we too must flip with it. So cool, the house is to the left of the tree. So when we flip back, there's no other option. The tree has to be way up there to the left of the doll. But that's due to our stories, to our language. You go play this same exact game with Northern Aboriginals. In the Northern Territory, a lot of the Aboriginal tribes, their language doesn't use egocentric language. All of their space is based on the cardinal points, north, east, south, west. So in this case, the house is south of the doll. When you flip the table, it don't matter. The tree is south of the house. So if the house is south of the doll, the tree is south of the house, then the tree has to be south of the doll. It doesn't matter what's going on. There is no egocentrism. South will forever be south, regardless of what the things are doing. Now, the interesting question to ask is, who's right? Are they wrong when they say the tree goes there? Are we correct when we say the tree should be in the other thing? No, our stories drive our perceptions. Now, just to see if you get this, I want you to imagine I sat you at a table and I took a little toy car and I moved it towards you and to your left. Now, I flipped you in that table and I said, I want you to move that car exactly the same way I just moved it. All of us, the vast majority of us, would move it towards us and to our left. Rock and roll. Now, play the same game with the Northern Aboriginal. How would they move it? So they're sitting at a table. I move it towards them, to their left. We flip the table. How would they move the car? Away from them and to the right. Why? Because the car was only ever going east and south. It doesn't matter where they're at. It doesn't matter where they're facing. Everything is linked to the cardinal points. Another example, this is story. This is memory. This is our perception. This is the power of our stories driving our coder driving our perception. Now, so what? We're here to talk about students and learning. Hopefully you're already starting to get some good kind of ideas on your own. But whenever I talk to my students, here's a point where we go, let's talk about studying for a bit. So as a student, when I say the word math, how many of you right now are thinking, yeah, that's my jam. I'm really good at that. And how many of you are thinking, oh, I'll never be good at math. I didn't get the math gene. Sorry. Well, congratulations. You could assume whatever your story is at that point, you're going to be 100% correct. What about English, Lit? Which students are good at reading, writing? Which ones will never read or write? Because I'm sorry, they didn't have those pieces. Well, congratulations. Whatever they're thinking there, they're going to be totally correct. Science, you got kids who are like, yeah, that's my bag. And you got some kids listening to this brain stuff saying, oh, I'll never get that. Well, congratulations. Whatever they're thinking, they're going to be right. And you got your sports nuts, the kids who can kick, throw, shoot. And the other kids who say, oh, I'm sorry, I don't got that machinery. Whatever they're thinking, they're gonna be 100% right. Because if our stories drive our coder and our coder drives our perception, then our stories about our skills, our talents, our abilities, those things we're good at, those things we're bad at, those things we can do, those things we can't do, those stories are going to drive this. It's going to change all of this. And that's going to be exactly what we get. Whether we think we can or we can't, we're going to be correct because we are driving this machine. Now, it's important to point out that the story is a good start, but it's not enough. Like you can't be, some people take this argument way too far. So let's say I've historically said I can't do math. And then one day I change my story to I can do math. In that moment, do I magically become good at math? Heck no. What do you still got to do? I still got to learn. I still got to drill. I still got to practice. I still got to put in the effort. The joke is that the story determines what impact that later practice will have on me. The story doesn't make me good. The story determines how my brain processes all later information relevant to that topic. So if I got a story that says I can't do math, I practice math for 5 hours, my brain will start to take it in. And as soon as I stop, my brain will go right back to normal. It's as if I didn't even do anything. But if I change my story to I can do math, practice for 5 hours, my brain will start to change. I stop and my brain will stay with that new information. It will hold on to it. So the story didn't absolve me from needing to do the learning. The story merely dictated what impact that learning would then have on me. So we can't take the argument too far, but hopefully you recognize it is the precursor to everything we do past here. So if we bring this back then to the ThinkPlus Journal, what you'll start to see, and I think it's good for you to start thinking about where does this align with you, with your practice as a teacher, with your students, with their practice as students, how we grade them, how do we think about topics. But in terms of the ThinkPlus Journal, we've got 4 activities that are kind of outlining what we're talking about now. Step 1 to understanding the coder is you have to understand it. You have to get your mind blown away by it enough to start thinking in those terms. So what we've done is the first 2 pages are kind of, you see we've got the cube kind of image that we played with in these images, those kind of visual illusions we were playing with the idea of tripping the students up and getting them excited and going, wait a second, maybe this thing doesn't work the way I think it does. Maybe the brain is more than just input, chug away on a computer, off I go. Once you've got people thinking in this term, once you've got their mind open where they think, wait, maybe things are different than I thought they were, then we can go into a couple of activities where we can start to mine the depths of our stories, where we can say, okay, what are your learning stories? What are those things you think you are good at? What are those things you think you will never be good at? What impact are you seeing that have on your actions, on your behaviors, on your thoughts? And if you change that story, what might happen beyond that? So once you've got them in that open mode, and we'll see why in a second, that's when we can start to really get them thinking about what is my own story. And if you can track your story over time, it's the best way to see it change. Like if I write down my learning story once now, cool. But if I do it now and in 6 months and at the end of this year and at the end of next year, I can see my progression as I'm growing and I can see my story changing. And then I can start to pinpoint where in my life am I seeing those changes manifest. As my story changes, what else is changing along with it? And that only empowers me to continue to push this progress along. Now, real quick, there's 2 more things I want to teach you. Yeah, I might skip this one. Don't worry about the next bit. I promise you're not going to miss much of anything. But I want to go into this last bit then is once we've got our stories, a lot of kids say, well, can I change my story? Or am I just kind of, because our cultural story is you are who you are. We're just watching individuals unravel themselves when the biological story should very much be completely different. You are creating who you are every minute. Every choice you make, everything you eat, everything you think, everything you dream, all of that is creating you minute by minute, second by second. Our genes, our cells, nothing is determinate. Absolutely nothing is. And the more we can start to shift that narrative, get them thinking, what you tend to see is a lot of kids, once they understand the coder and they start thinking about their stories, is they wonder, can I change my story? And the answer is, of course you can. Now, I got to skip all this, so apologies for that. So how do we change our story? There are kind of 3 ways in this journal that will help them kind of recognize. Way number 1 is choice. Once you recognize the coder and how all of this works, at any time you want, you can tap into it. You can access your coder and start to change things as you want to. This, by and large, is the point of meditation. This is where you get the impact of mindfulness. This is where you get the oomph of things like prayer. This is where things like CBT, psychology, is based almost entirely on this concept of activate your stories till you know it's active and then do something different with it. So a lot of the practices that you'll see, not only in this, but wider for students, is going to be this idea of choice. Once you have the knowledge of the system, you can start to tap into the system at will. 2 is engage with learning. Another way to tap the system is to learn. If you ever want new information to enter into your stories and change your perception of the world, it has to go through your coder. So anytime kids are at school, the vast majority of their schooling is us trying to help them update their stories through the process of learning. So the more they engage, are a part of the learning process, without even knowing what the coder was, it will automatically kick on and start to change this. The mechanisms can help. Once they know what's going on, it gives them more impetus to engage with learning, but just know that learning, the process of learning, is the process of change going through this system. And way number 3 to access your coder is probably the hardest to get right, but the most powerful, hands down, is this. So I want to just start with a quick pop quiz, just an easy pop quiz to get us all, on easy footing again, because it's a big session. So here's our pop quiz. How many senses does the typical human being have? Not a trick question. I'm guessing you're all doing fine. What do we got? We got 5, right? We got sight, we got smell, we got taste, we got hearing, we got touch. Wonderful. So everything in the world makes sense. Now watch what happens when I swing by and I say this answer here, 5. Oh, it's completely and utterly wrong. In fact, it's not even close. The last time we counted, everyone on this call will have anywhere between 17 and 21 unique senses in your body. Now stop. What might have just happened here? The number 3 way to access your coder and start to actually physically change your stories is through errors, mistakes. When something about how you think, when you have a story for the world and that story in reality clash strong enough, you don't have a choice. Your coder goes live and says, update, update, update now. It's a safety mechanism. Your brain doesn't know if you're going to live or die. So anytime your story and reality are just at loggerheads, your brain says, forget your story, change, take in reality, and let's live in this for a while and update your story. I promise you, you'll never learn better, faster, easier than right after you screw up, because literally, biologically, the whole machine kicks into gear and says, update, update, update. The problem with this is here. So when you make a mistake, you don't have a choice. Your coder goes off and says, let's change your story. But once your coder goes off, you do get to choose what you do with it. You can choose to engage with it, stick with that feeling and go, okay, cool. In which case your brain flips into a mode called theta, and simply put, this is just a sign that you are updating your story. Something is changing in you. But if I can choose to engage with that error, guess what my other option is? Oh, shut it down, avoid, disengage. My coder goes off, says update, update, update. And I say, no, I don't think so. Cool, brain will go into beta, will work to erase that error. And about 72 hours later, I will make that same mistake again. It will be gone from my system and I'll go right back to my old story. Now, what do you think most human beings choose when we make an error? To engage or avoid? We almost always avoid. Why? Because it is so much easier. It takes so much time, effort, energy to build a story about the world. Anytime we have to change it, most of us just go, nah, I'm happy with where I'm at. But the secret to everything our kids want to do boils back down to here. Is engage. When we screw up, we don't got to like it. We don't got to love it. I'm 40 years old. I hate messing up. Point is, we've got to depersonalize it and start to recognize it. What is that mechanism? Because I now know what the coder is and what the sensation is and what failure is trying to do, I don't take it personally. I still hate it, but I'm more apt to now stick with it, engage with it, and start to change my story. And that's it. The difference between the highest and the lowest echelon of everything is right there. When you screw up, do you engage? Or do you shut it down? You engage, you continue to grow and thrive. You shut it down. There's no right or wrong answer, but you'll just plateau and run the same story. And I'm going to leave you with this just to show you how deep that kind of concept goes. Yep. Okay. I'll be quick. Sorry. I apologize. We're running a little late on time. So our story's just final story for the day is here. So Lewis Terman. Now you guys all know about IQ tests. And if you want, I can talk your ear off about how pointless they are and how absolutely nonsensical that whole concept of intelligence is, but what are you going to do? So back in the 30s, when IQ testing was kind of new, there's a guy named Lewis Terman who loved him. He thought IQ was everything. He said, look, if I know your IQ number, that's going to tell me everything I need to know about you. So convinced was he that he went down the coast of Southern California, IQ tested 40,000 kids under the age of 12 and picked out his top 1,500, the one with the highest IQ. And he said, everyone watch. These kids with the high IQ, they're going to be the game changers. They're going to be your wealth makers, your CEOs, your politicians. These other 39,000 kids, they're cute, but they ain't going to do much. These are going to be the world makers here. And what happens? He follows those kids for the next 40 years. Now take a guess. Of those 1,500 students with the highest IQ, how many do you reasonably think could be called game changers or even important in your field? I'll give you a hint. It's less than 5. Give you another hint. It's less than 3. Final hint. It is less than 1. Yes, the answer was 0. Not a single one. So angry was Terman that he just started to refer to them as his termites. Now, what happened? What went wrong here? Fact 1, IQ doesn't tell you anything about anything. IQ tells you how well you're probably going to do at school. It's about as far as that's going to tell you, but we won't go into that. But more importantly, you give me 1,500 people randomly. At least one should do something of note. How is it possible all 1,500 did nothing? I mean, they were normal people. Some had jobs, some didn't. Some went to prison, some became scientists. They were just a normal group of people. Just no one did anything crazy. How is that possible? Well, we did our research and you can probably figure out the answer. Turns out Terman did something real stupid right at the beginning of his study. He told all of his students where they were. He told these 1,500, you're a genius, you're going to change the world. And he told the other 39,000, you're not going to make a difference in this world. Now, what impact would that have? Now we can find out. You give me one of Terman's termites. I pop them in a scanner, they make a mistake. Their brain will almost invariably go immediately to this mode. Now, what do you think that is? Engage or avoid? Avoid. Why? Why would a genius, every time they screw up, just shut down immediately? Because if you're a genius, you only got 2 choices. If I'm a genius and I'm wrong, either I'm wrong, which can't be true because I'm a genius, or 2, the world is wrong, which must be true because I'm a genius. Essentially, all these kids just plateaued. He stunted them by telling them you're a genius, you're going to change the world. They were running the same stories at 80 as they were at 18. They just never grew. Now let's take a look at someone else who is growing, a real game changer. So here's Isaac Stern. You probably know him. He was big when I was growing up. One of the best living musicians, changed the way we teach the violin. Huge game changer. Turns out he was IQ tested by Terman as a kid and he was deemed too stupid. You're not going to make a difference. Well, Stern, how'd you do it? It's only through failure and through experiment that we learn and grow. William Shockley, IQ tested by Terman as a kid, deemed too stupid. This guy goes on to win the Nobel Prize in Physics for inventing the transistor. The thing that is allowing this phone call to happen, all modern technology, is thanks to this man here. Massive game changer. How'd you do it, big guy? Transistor was created by making errors and following hunches that failed to give what was expected. You give me a real game changer, someone on the edge of a field who's moving and shaking. I pop them in a scanner, they screw up, their brain will immediately go into this mode here. And what's that? That's engage. And that's it. The big difference between the haves and the have-nots and the tops and the bottoms is when you screw up, do you stick with it or do you shut it down? Stick with it, you will continue to grow. You don't have a choice. Biologically, everything is going to move. Shut it down and you will plateau and you will run the same stories. So when it comes to using errors to help us change our stories, it becomes about depersonalization. Recognize the machinery, the system. There is just patterns here. Learn to depersonalize it. It's not you screwing up. It's not you going into fight or flight. It's the coder kicking on. It's biology saying we need you to help us update. And once you learn you're running this machine, it's just trying to help you run the system. Then it's a lot easier to depersonalize and start changing. So also in the journal, we go through those kind of concepts and help them have a think about specifically with their own errors and their own mistakes. How do they feel? How do they deal with them? When do you make good mistakes in your life? Have you ever made a mistake that helped you learn? Where do you tend to turn it off? And can we start to get our own patterns? The big trick with metacognition and with the coder and with all of this is awareness, 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 awareness. That is it. We can give you tips and techniques and tricks and but what we've done educationally for so long is we've tried to Trojan horse that into our students. We've tried to sneak that in through our teaching. When now we're starting to learn, no, they've got to be part and parcel with it. Don't try and get them to love errors by sneaking in errors. Tell them flat out, here's what an error is, here's what it does, now let's play with it. The more they see behind the curtain of learning and recognize it's just a series of patterns and you're allowed to game those patterns, the easier it is for them to start to take agency, ownership over the system. And that's the crux of metacognition. The more you know, the more you're able to run this yourself. So thank you guys. I apologize for taking you a couple minutes too late. If you need to run out, don't worry about it. You're not going to offend me. But if anyone wants to stick around and ask any questions, I'm happy to stick around a bit and have a chat. So thank you guys so much. And I hope that made sense.
Wonderful. Thank you so much. That was terrific, Jared. Thank you. I I've just been mesmerized. I can't, I can't thank you enough for being able to explain that highly complicated information about neuroscience, about the brain, right down to the level of activities for kids. It's just made so much sense, your entire presentation, especially about the explicit knowledge that kids need, even using the terminology of metacognition. I don't think we shy away from that. I think we need to tell them what these things are called and to get them to use that language of thinking.
Yeah.
So
the big movement in the next 5 years, especially here in Australia, is going to be transfer. Like South Australia is going on to a new curriculum where it's all based on transfer, and they want movement of skills. And that's the big joke, is everyone says, so how do we teach kids transfer? They did all these decision making and said, well, we want transfer, how do we do it? And that's the big secret, is you don't do it. You teach them the word, you teach them the process, and then you just make it part and parcel of every single day. Like with my students, if I don't say the word transfer at least once a day, then I haven't done my job. There is no way to trick this stuff in. We just bring them on board and off they go.
Absolutely. I couldn't agree more. We do have some questions, Jared. So if you've got some time, we might just take a couple, if that's okay.
Yeah. That's fine. Did they ask you, or do you know, are they in the chat? Let me take a look at the chat.
Yeah, they've been in the chat. I've sort of collected them. We've got a question from Bron Ray Jones, who is a
hey, Bron.
Educator.
I know Bron, yeah.
Yeah. So she's got a question about the difference between stories used in this context and knowledge or schema. But Bron, I'll ask you to unmute, or Scott, if you could ask Bron to unmute so that she can ask her question.
I think I know where you're going, Bron, with it. Is in this instance, stories is schema. It's the exact same term. It's just a simplified. So if we were in a lab, we would be saying schema or schemata. It's how are you piecing your knowledge together into a coherent whole. But I just, for this instance, it's easier to use the term stories, because some kids are like, what do you mean by schema? Or if you start talking about concepts, some people get really tripped up. So in this case, we're just talking about how does your information glom together?
So with that, so in this context, you wouldn't say stories would be more synonymous with knowledge rather than mindset?
Yes, it's tricky. So knowledge to me, and I'm just going to break this down real fast, so just bear with me. So knowledge is facts, and then concepts or understanding would then be schema. How are you building those facts into a coherent unit? So in this case, stories would go along with that understanding, with that schema. Mindset, so far as I'm concerned, will live like slightly above it, in the terms of, if you have a story that says, I can't do math, by and large, that story is going to come from whatever experience you've had of math in the past, whatever people have told you, if your parents have told you. So you're going to have a schema where math is untouchable to you. So I think mindset is kind of like an overarching umbrella, but I think the stories that kind of impact the coder can be sitting there, but it's largely going to be based on how is your knowledge glommed together, then what's that driving. Does that kind of make sense?
Yeah, it does. I was just thinking from like a primary school perspective, I get really worried about sort of growth mindset interventions run in sort of the absence of thinking about domain specific knowledge and how competent you are in a domain.
And you'll see, that's why, believe it or not, of all the, if you ever, like, I'll do 10 years of learning with me, you'll probably never hear me use the term mindset, because I'm not 100% sure what it is.
Yeah.
I get the idea, but it's a lot easier just to talk about stories, knowledge, schema for me. Like you can even tell just answering you, I'm not 100% sure where to throw, because it sounds like its own little standalone bubble. It's almost like when we talk about personality and then people talk about dispositions. It's like I've never been able to separate a specific personality trait versus a disposition. The two don't make sense, and I can only understand dispositions through the traits. So I pretty much only just talk about that stuff.
Thank you so much.
No worries.
Thanks, Bron. Thanks for your question. Just on that, we talk about mindset in ThinkPlus, and we talk about it in terms of a mode of approaching a problem. So
Yeah.
it's, what sort of mode are you in when you to approach learning problems, really? And it makes sense to then, in domain specific knowledge within a curriculum content or domain learning area, to think about how you approach that specific information.
You know what's can I'll throw a I started, you guys know Dune. I'm a sci-fi
yeah,
geek.
Dune. Yeah.
And Dune is coming out as a movie. I'm
Spice.
pumped. So I started rereading Dune because the movie. I'm ready to go for it. And I totally missed this the first 100 times I've read Dune. Yes, I'm a geek. There's a quote, and I'm gonna butcher it here, but they're talking about Paul, and they say people always wondered why Paul moved so fast or was able to learn so much better and easier than everyone else. It's because his very first lesson was in learning how to learn. And the very first lesson of that was he learned that he was able to learn. It's shocking how many people think they can't learn. And I read that, I'm just like, dang, that's essentially that's everything I've tried to teach, because it boils back down. Maybe that's where mindset is. The very first lesson is you have to know that you can learn. Because if you have a belief that you can't learn, then everything it's like, dang, I can beat my head against the wall all week and nothing's going to change. So learning how to learn, that's metacognition, but knowing that you can learn, maybe that's where a mindset sits.
I think you're right. We've got a question from Bernie Lanyon at Kingswood College, and Bernie.
Bernie,
it's
not actually a question, it's a comment.
Okay.
Many people mightn't know, but I've been ThinkPlusing for a million years. And Bron, in sort of relation to what you're talking about, of my past probably 3 or 4 years, no more than that, of actually being back in the classroom teaching, I don't actually use the word growth mindset at all, because I think it's been killed a little bit and it becomes just a catchphrase. Oh, use a growth mindset. And I think what you're referring to is it can become a tokenistic thing that means nothing. And approaching it in the way Jared talks about it, in changing the way they think about how they can learn, going from I can't do maths, or maybe I can do maths if I try hard and I work, and you give all that sort of story behind it, makes such a difference. But that word growth mindset does not enter my classroom anymore. I'm sorry, hello, ThinkPlus, but I think it got a little bit killed in its translation, which is a shame, because it basically just means that we believe we can change our brain, and that's the message I give kids. So I just thought I'd put my little bit in there.
Yeah, it's true. It's that hype cycle it became so popular that it had to crash and burn. Oh. But now that it's crashing, it will come back out, and then it will find its nice little spot at some point where people will say
in a nice way, in a much more powerful way.
Yeah.
It was just grabbed and run with, I think, and probably done pretty poorly in many places. But having your knowledge behind it and that really scientific side to it has really changed the whole, I think, the look of ThinkPlus and the way that we teach in the classroom, and even using the journal too.
It's interesting. I was talking about that. If you take a look at, and this kind of will come back to, if we have our growth mindset and our fixed mindset, and everyone says, I want my kids to have a growth mindset. I'm like, that's fantastic. Why do you want it? And where I stand on that is because it's true. So far as I can tell, I want my kids to believe the earth is round. Why? Because it's true. I don't want it to be a belief. I want them to be like, yeah, that's at least something we can hang our hat on. When it comes to growth and fixed mindset, everything we have ever learned about human biology is that it changes, is that it's adaptable. Therefore, if you have a growth mindset, or excuse me, a fixed mindset, you're just flat out wrong. I don't want you to have that mindset, not because it's going to impact your learning. I want you to know how biology actually works, so that you're not stuck thinking something that's totally untrue. So if I ever, anytime, my wife did it this morning. So I'm working on a documentary now on Genius. And one of the things we're doing is we're training 2 people. We're training, like, one person is doing 2 months and they're going to become an absolute gun billiards player and never played pool before, but we're just showing you that if you do the right stuff, it doesn't matter that you've never done it, you're going to get good. My wife said, I don't think that would happen with me. And I'm like, how many more times do I have to show human beings that that thing right there is just nonsense? You can choose to not learn pool. I have no problem with somebody saying, I don't have the time for it, or I don't care enough about it. But when somebody says I can't, I'm like, No, go read 100 years of neuroscience. Everything we've ever learned says every human being can achieve any feat with the right material, with the right structures. That's it. That's the big takeaway. It's then a matter of what do you want to do. And so that's what, whenever anyone talks about fixing growth, I'm like, I want my kids to have a growth mindset because it's right. I want them to have a growth mindset the same reason I want them to think eating vegetables is better than eating a candy bar, because it's just right. I don't know what else to say.
And teaching them not about growth mindset, teaching them about how their brain continually changes. Teach them that science.
Yeah.
You know, from prep, teach them to draw neurons and neural connections, and it becomes a part of them where they don't think about, I can't do it. I can't do it yet. I need practice. I need expertise. I need to continue and to strengthen that connection. Yep. If that starts at prep, it makes a dramatic difference.
Boom. So I'm with you. I wholeheartedly agree.
I'm just wondering, can everybody see my screen?
Yeah.
Yeah, great. So Bron just also brought up another point about that sort of shallow kind of learning around mindsets. And I guess I wanted to let you know that, you know, within the journal, the different types or the different chapters, we've taken best evidence research and really focused in the mindsets and emotions chapter more around the theory of constructed emotion and emotional granularity based on Lisa Feldman Barrett's work, to really get kids to understand that mindset is strongly connected to language development. So if you don't have the word for it, then can you feel it? Kind of that old name it to tame it type way of thinking. And we found that within that, we've been able to explore mindset, I guess, as a mode, as I said before. But absolutely, Bernie, with your comments around neuroplasticity and understanding just the physiology of the brain is just as important as understanding their thinking and reflecting on their own thinking.
And I think, can I jump in? I think Beck made a good point that I just want to clarify so I don't leave anyone going,
no, don't. I was going to get back to the questions. Go ahead.
Yeah. Beck made a point that says, what about disability? So very good point. So what we tend to say is, at a healthy level, any human being can achieve anything. We've never found a limit in a healthy individual. Once disability comes in, and it's a very real thing, the trick with disability is the process of learning doesn't change. It's just the structures around it. So if you're born with no legs, and watch, I'm probably going to butcher this because everyone will always prove me wrong, but there are certain disabilities. If you're born with no legs, you're probably not going to dunk a basketball until somebody does, and then I'm proven wrong. And that's always what happens with history. But there are going to be some limitations based on disability. The trick is, once you flipped from disability, a very clear structural problem, into what we call health, where we can't see there's nothing structurally wrong, then we're then into that ball game where we say everything is the same. And beyond that, everyone still learns the same. Like if you got a hole in your heart doesn't work differently. If you've got celiac disease, your stomach doesn't work differently. Everyone's system still works exactly the same. And that's one of the big things when you work with special ed, is a lot of people say, okay, I've got a dyslexic kid. How do I teach them how to read? I've got this ADHD. How do we teach them? And the big secret from 30 years of special ed is you do exactly what you do with everyone else. You just do more of it and for longer. That's it. The system of learning doesn't change because you have a disability. We all breathe the same way. We all digest the same way. We all learn the same way. We have for 150,000 years. When people say people learn differently, no, the biological mechanism of learning does not. If you learn differently, you're not a human. That doesn't change. You might like different things. Different things might resonate more with you. You might want to go through a window when someone goes through a door, but the process stays the same. And it's that process that we want to get across to kids. That is learning. That it does. If you know the process, then you can make your decisions as to what inputs you want into that process. So I hope that kind of makes sense. I don't know. If we were together, I'd see everyone, but yeah, just guess.
I'm just going to share my screen. We've had a call for some more information about your website, Jared.
Oh yeah, if you just go to on YouTube, that's where you're going to see most of my fun stuff. So if you go to just look up Jared Cooney Horvath on YouTube.
Everybody to go and have a look. Yeah,
that is. We're doing we're right now on a series of genetics. So the last 2 are on genes. We're going into heritability, showing that genes don't work the way you think they do, and that they're just as malleable as everything else in the system. And so that's it. So just every couple of weeks, we put out a little 5 to 10 minute video on a new piece of research. So if you're really liking the science of learning stuff, that's just a really good resource where you can get a new hit every couple of weeks on a new topic that might open up a way of thinking or something you might want to do.